Hello and welcome to The Explainer. Today, we are diving deep into a journey, not across some distant land, but through the most complex and amazing landscape in the universe, the one right inside your own head.
So, let me just start with a quick question for you. Do you think the brain you have right now is pretty much the same one you had when you were a kid? You know, that it's a fixed, static thing, basically set in stone after a certain age? Well, if you thought yes, get ready to have your mind changed. The truth is, your brain is a dynamic, constantly evolving masterpiece. It's less like a stone monument and way more like a living, bustling city, with new roads and buildings being constructed all the time.
Okay, so let's start our story where every hero's journey begins, in the ordinary world. And for your brain, ordinary means a state of constant, quiet adaptation. Now, the fancy scientific name for this superpower is neuroplasticity. But all it really means is that your brain has this incredible ability to reorganize itself. It can form new connections between neurons, and it can literally change its own structure and how it works based on everything you do, think, and experience. And here's the kicker. This happens throughout your entire life.
So what's up with this number, 700? It's not just random. Research tells us this is roughly the number of brand new neurons that your hippocampus, which is a super important area for learning and memory, creates every single day. The process is called neurogenesis. So think about that. Your brain isn't just rewiring itself, it's actively building new hardware, day in and day out.
But what happens when our hero, the brain, faces a sudden disaster? You know, an inciting incident like a stroke or a traumatic brain injury that threatens its very existence.
So a stroke, at its core, is a massive disruption of blood flow. The most common kind is an ischemic stroke. Think of it like a dam suddenly blocking a river. A blockage just cuts off the supply of oxygen and nutrients. A hemorrhagic stroke is more like the riverbank bursting. A blood vessel actually ruptures, causing a really dangerous bleed inside the brain.
Now here's where it gets really weird. It's a total paradox. You'd think the cells die from starvation, right? Makes sense. But the reality is much stranger. The cells that are starved for nutrients actually go into a state of hyper-overdrive, this destructive frenzy called excitotoxicity. They literally burn themselves out.
It's this devastating chain reaction, a real chemical cascade. First, without energy, the cell's pumps fail, and sodium just floods in. That triggers step 2, a massive, overwhelming release of a neurotransmitter called glutamate. This glutamate flood then forces certain receptors to stay open way too long, leading to step 3, a toxic overload of calcium. And finally, that calcium overload, that's the killer blow. It destroys the cell's power plants, the mitochondria, and leads to cell death.
But our hero does not give up. After the crisis, the brain begins one of the most remarkable comebacks in all of biology. This is its resurrection.
This healing journey happens in stages. Right after the injury, things look bleak. The surviving cells kind of shrink their connections and go quiet. But then, starting around the first week, the fight back begins. New connections or synapses start sprouting all over the place. Key growth factors ramp up, and by the first or second month, a full-scale network reorganization is happening. The brain is literally redrawing its own maps to work around the damaged areas. It's incredible.
So how on earth does it do that? How does this rewiring actually work? How can one part of the brain just take over the job of another?
Okay, this table shows something absolutely mind-blowing about brain activity in amputees. For those with phantom limb cane, when they simply move their lips, not only does the face area of their brain light up, but so does the old, unused hand area. The brain's real estate for the face has basically invaded the hand's territory, and it's this cross-wiring that's thought to cause the phantom pain. It's just a stunning, real-world example of that cortical reorganization in action.
And this brings us to the final, and maybe most important stage of the journey. The brain is the hero of this story, for sure, but you can be its most powerful ally. It's time to talk about the elixir, the tools you can use to help it not just survive, but thrive.
And this elixir isn't some magic potion hidden in a cave. It comes down to 3 things you can control every single day. These aren't just healthy habits, they are powerful levers that directly shape your brain's structure and its potential. We're talking about exercise, diet, and learning. Let's break them down.
First up, exercise. When you get your body moving, your brain releases a crucial protein called brain-derived neurotrophic factor, or BDNF for short. Honestly, the easiest way to think about BDNF is as Miracle-Grow for your neurons. It helps existing neurons survive and grow, and it encourages the birth of new ones.
And you can actually see the results. This chart comes from a huge analysis of studies on older adults. The folks who did aerobic exercise showed major improvements in brain function compared to those who didn't. And just look at that huge boost in executive control. That's your ability to plan, focus, and multitask. It's a game changer.
What you eat is just as important. Studies on rats show a really stark difference. A typical Western diet, high in fat and sugar, leads to lower levels of that Miracle-Grow molecule, BDNF, and way worse performance on learning tasks. But compare that to a diet low in fat with complex carbs, it boosted BDNF and improved learning. You are literally feeding your brain the building blocks it needs to grow.
And finally, learning. Pushing your brain to learn a new, complex skill forces it to change. It has no choice. Get this. Studies showed that after just 3 months of learning to juggle, people actually grew more gray matter in the part of their brain that processes visual motion. And professional violinists have a way bigger brain map for the fingers of their left hand compared to non-musicians. So the takeaway is clear. Practice doesn't just make perfect, it physically builds a bigger, better brain.
So, where does this whole journey lead next? Well, science is now figuring out how to harness this incredible power of plasticity to develop some truly cutting-edge therapies for brain repair.
The progress here is just amazing. We're talking about scientists designing super-targeted rehab to put recovery into overdrive, exploring stem cells to help rebuild damaged tissue, and even using magnets and gentle electrical currents to guide the healing pathways in the brain. But in every case, the goal is exactly the same: to work with the brain's natural plasticity to help it make its heroic comeback.
So let's wrap this up. Your brain is not a static object. It is a living, growing, and unbelievably resilient hero, constantly on its journey. It's ready for whatever the next adventure is. The only question left is, how will you help it?